Proof by induction. This is an inequalities example for Leaving Cert higher level. Prove by induction that 2 to the power of n is greater than n squared for all values of n greater than or equal to 5 where n is a natural number. So the first step in proof by induction that we do here is we input some value for n, usually the smallest value of n possible, and here we're told that's n is equal to 5. And when we sub that in, we see, yes, it does work, that 32 is greater than 25. So it's true when n is equal to 5. Now what we're going to do is always assume that it's true for the value n is equal to k. So if we sub k in for n, we're saying that 2 to the power of k is greater than k squared when k is greater than or equal to 5 and k is a natural number. So we're assuming that to be true. And now our task is to prove that it's true when n is equal to k plus 1. That's what we want to prove. Okay, so let's evaluate this. The important thing to know is 2 to the power of k plus 1 is 2 times 2 to the power of k. So it's true if 2 times 2 to the power of k is greater than, and we'll expand the left hand side, we get k squared, square the first thing, multiply the two elements and double it, square the second thing. That's k squared plus 2k plus 1. Now two groups of 2 to the power of k is 2 to the power of k plus 2 to the power of k. In the next step, we're going to use the assumption. We know that 2 to the power of k is greater than k squared. So this whole expression would be true if the other part on the left hand side was bigger than the right hand side, if 2 to the power of k was greater than 2k plus 1. But we know 2 to the power of k is greater than k squared. So if k squared was bigger than 2k plus 1, well then that would have to be true as well. We're going to rewrite that as a quadratic. So I'm taking 2x and taking 1 from both sides. So how would I prove that this expression is greater than 0? I might like to factorize it, but it doesn't factorize easily. So the best way to do it, rather than using the formula, is write it in complete square form. When I write this in complete square form, I can see it being written as k minus 1 to be squared minus 2 is greater than 0. So is this true? Well, remember k is greater than 5. So what we're asking is k minus 1 to be squared greater than 2? Of course that's true if k is greater than 5. So we've proven what we set out to prove. The final step of induction then is we state our claim. So what we are saying is it is true for n is equal to k plus 1 if it's true for n equals k. We have shown that it is true for n is equal to 5. Therefore, it is true for all values of n where n is greater than or equal to 5.